There are situations when we are given a function, the whole of which is raised to a given power, and we are required to differentiate it. Then, in that case, the power of a function rule is used to differentiate the same. So if we are given a function of x, which is given as a particular function, the whole of which is raised to a particular number, where u is differentiable function and n is a real number, then we find the derivative by taking n times the whole of this function that we have here raised to power n, we subtract 1 from the power, times the derivative of this function that has been raised to this power. So we have an example here. We are given y is equal to the whole of this raised to power 2, and we are supposed to find dy over dx. So first of all, if you relate the two, you realize our u of x is whatever that's in the bracket here. So we can say let u be whatever that's in the bracket here, 3x raised to power 4 plus 2x cubed. The derivative of this will be u prime, or u prime of x is equal to, or you can also call it du over dx. Remember, it means the same thing, whether you say du over dx or you say u prime of x, both denote that you are differentiating. So the derivative of that will be, bring this 4 here, you multiply by 3, you get 12, x raised to power 4 minus 1 gives you cubed, plus bring this 3 multiply by 2 here, you get 6, subtract 1 from the power, you get x squared. That's the derivative of u, in other words, the derivative of the content of the brackets. So we now write the derivative of this function, the whole of this function, as follows. dy over dx will be equal to, as we have said up here, you bring the power and multiply by it here, and then we shall subtract 1 from the power. So we have 2, we have brought this power from here, multiplied by the whole of this function, then write the whole function, subtract 1 from the power. So we have 2 into 3x raised to power 4 plus 2x cubed, then raised to power 2 minus 1, times the derivative of what was inside here, which we have calculated here and found to be 12x cubed plus 6x squared. So we have first of all taken these 2 here, multiplied by the whole of this, then raise it to power 2 minus 1. Then when we finish that, we multiply by the derivative of the content, like that. So we can remove this multiplication sign and just write this one as in a simplified form as 2 into this raised to power 1, then times this one here. But remember, when you have something raised to power 1, we can just ignore the power. We know that when the power is not there, it's like it's raised to power 1. So that's what I've done here. Then we are now multiplying this, and this. If we start multiplying 2 by what we have in this first bracket, in an effort to simplify, we shall have 6x raised to power 4 plus this times this, giving us 4x cubed. Then multiply by the whole of this bracket. Now we want to simplify further, so split this bracket and multiply each of the terms by this bracket. So we shall have 6x raised to power 4 times the whole of this, and then plus 4x cubed times the whole of this again. Then we now multiply this times this, gives you 72x raised to power 7. Remember, when you are multiplying indices, we simply add the powers so long as the bases are the same. So 6 times this 6 gives us 36. X raised to power 4 times x squared, you add the powers, you get x raised to power 6. Then this times this gives us 48 x raised to power 6. And this times this gives us 24 x raised to power 5. These ones can be simplified, they are like terms, so we shall have it being equal to 72 plus this gives us 84 x raised to power 6, and then plus 24.